Okay, so now you know that we have inheritance, and inheritance there is a class, and that class has methods and variables. We also have the second class, and in the second class, which is the subclass, it inherits all of the data and all of the methods from the first class, right? So here I want to let you know about a new notion which is called polymorphism and explain it to you. In polymorphism, if we have a piece of code which is designed to work with an object of type X, then that piece of code will also work with an object of a class type that is derived from X. It means the subclass of the X. So this feature is actually polymorphism. Polymorphism by Java interpreter is implemented through a mechanism that is called dynamic binding. For example, consider that we have a class named shape. This class be our superclass. Then we have rectangle, triangle, and circle as our subclasses, right? We can create objects from each of these subclasses. How? As you see here in this example, shape S1 equals new circle, shape S2 equals new rectangle, shape S3 equals new triangle. So as you see, we are creating one object from class circle, one object from class rectangle, one object from class triangle. So now, if, for example, in our class shape, we have one method with the name of find area, we can call this method from these subclasses. Actually, since this method exists, for example, in the shape class, even if it be an overridden method in circle or rectangle or triangle, we can call this method through dynamic binding. So S1.findArea actually runs the findArea method that exists inside the circle class. S2.findArea will run the findArea method from the rectangle class. S3.findArea runs the find area method from the triangle class. Now, if any of these subclasses did not override the find area method, then for any of these calls, the find area that exists inside the shape method will run. Another point in polymorphism and dynamic binding is that when we have a class and that class is a parameter for example a method, then we can pass in an object of a type derived from that class to that method as well. For example, we have a method named draw. As you see, this method as a parameter accepts shape S, right? So if we have objects S1, S2, and S3, S1 be an object of shape, S2 be an object of circle, and S3 be an object of rectangle, we can pass in any of these objects into this method. So draw S1 will run the method draw by having S1 as the parameter. Draw S2 will run the method draw by passing the S2 as the parameter. So as you see, S2 is a circle object, right? Draw S3 will run the method draw, right, by passing the S3 as the input parameter. As you see, S3 is a rectangle object. Okay, now you know what is actually what it means by polymorphism, right? So here I want to let you know that a very important application of polymorphism is that it lets you um, to store those items, I mean those subclasses inside a container. This container can be an array. So actually you can store all of those subclasses inside one array. So each subclass as you know as a cell, as a value of one cell of that array, and then by having that array you can do some operations. For example, In the previous slide, I showed you a very simple example. We had a superclass shape, and then we had subclasses, right? Circle, rectangle, and triangle. Okay, so by having objects from these subclasses, we can store these objects inside one array. And then, for example, if we want to find the area of these objects, we easily can do that by a for loop. So we will have a for loop, and we will iterate through each cell of that array, and we'll find the area. We'll run the find area method of each object. So here you see this example, okay? First, we create an array of shape. Shape list be new shape. Then each cell, list 0, list 1, list 2 is one object. List 0 is new circle. List 1 is new rectangle, an object from rectangle. List 2 new triangle, an object from triangle class, right? So I have these objects and I will store them inside my array. Now I know that I have the method find area, right, inside the shape, or probably this method is overridden for each uh, subclass, right? So now by having this array, I can easily run find area method for all of these objects just by implementing it through one for loop. So for int I, as long as I is less than the length of the list, I'm going to print list I dot find area, right? You see that how much it's simpler to run this simple method that is common among all of these subclasses by storing these subclasses, the objects of these subclasses inside one array, and then running that method. So that's a very good, very important application of polymorphism. So let's see what is casting. Since a derived object can always be attached to a corresponding base class reference variable, this is a type of casting that is implicitly allowed. Similarly, direct assignment between variables in this order is also allowed, as are explicit cast operations. For example, we have shape S1, S2, so shape is the base class. Circle C, circle is a derived class. S1 equals new circle. Automatically, as you see here, it is completely legal. Then we have S2 equals C. This one is also automatically legal. S1 equals shape C. In this case, explicit cast has been used, right? So in order to convert an instance of a superclass to an instance of a subclass, the explicit cast operation can be used, right? For example, we have, for this case, for shape S1 and circle C equals S1 is illegal, but C equals a circle S1, as you see, because its explicit case is completely legal. The instance of operator checks to see if the first operand is an instance of the second operand or not. And then we'll return a response of the type Boolean. For example, we have shape S1 and circle C1. So we want to check whether S1 is the instance of circle, right? So we will write if S1 instance of circle, then a statement. For example, in this case, C1 be circle S1, right? So for this case, let's see a very simple example. So let's see a very simple example for shape and circle. So we have public class shape, then this shape has color, so protected color, protected Boolean field, it has some constructors, public shape, system.out.println, running shape constructor, color b color dot blue, field b false, public shape color c Boolean if, system.out.println, running shape constructor with params. Then we have color C field F. We have the method public void set color C, then color C, public void set field Boolean F, then field F, public color get color, return color, public boolean get field return field and public void draw. System.out.println starts the drawing of the shape. Right, so that's our class, right? Then we have class circle extends shape. So this class is the class circle derived from class shape. Private int center x, private int center y, private int radius. Then we have constructor circle. So public circle super, right? So this one invokes the parent constructor for this object, right? Then system.out.println running circle constructor center x equals 0, center y equals 0, and radius equals 1. Then we have another constructor, public circle color C boolean f int cx int cy int r super cf. System.out.println running circle constructor with params, right? Center x equals cx, center y equals cy, and the radius equals r. Public void draw super dot draw system dot out dot println running code in circles draw. Right, so this is one method that invokes the draw method, right? from shape, this one, and also we'll print this message. And finally, we have the last method, public int get radius, return radius, right? Import java.awt.color. Right. Then we have the final class, which contains the main class. So in this class, public static void main string args system.out.println building a shape object s shape s new shape, right? System.out.println building a circle object attached shape s2 the new circle system.out.println declaring circle C2 circle C2 be new circle color.red through 100 250 system.out.println calling c.draw c.draw system.out.println calling c2.draw c2.draw system.out.println c dot get radius return c dot get radius, right? And system.out.println c2 dot get radius returns plus c2 dot get radius. And finally, if S2 instance of circle system.out.println circle S2 dot get radius. So this is the final input of the previous example. So there are some points that you need to know. First, the interfaces Java does not allow multiple inheritance. A subclass can only be derived from one base class with the keyword extends. In Java, the interface can obtain a similar effect to multiple inheritance. Interface, a construct that contains only constants and abstract methods, right? Similar to abstract class, different since an abstract class can also contain regular variables and methods, and can use as a base type name just like regular base classes. And it's good to know that it cannot instantiate like an abstract class. Format for declaring an if interface is as you see here, modifier interface name, right? And then as you see, the statements, and you can use the keyword implements to state that a class will use a certain interface. In this example, for example, comparable is the name of an interface. The class comparable circle inheritance the data from the comparable interface and would then need to implement the methods to be able to use them, right? So we have class comparable circle extends circle implements comparable. There are some other rules that is good to know. So only single inheritance for classes with extends interfaces can inherit other interfaces with extends. Public interface, new interface, extends interface 1 to interface n. Classes can implement more than one interface with implements, right? Public class, new class extends base class implements interface 1 to interface n, right? See the clonable interface, a special interface in the java.lang package which happens to be empty. So it's public interface clonable. This is a marker interface. So it doesn't have any data, it doesn't have any methods, but it has a special meaning in Java. A class can use the clone method only if it implements clonable. So that's a point that you need to keep in mind. So let's see some examples. Okay, let's see some other examples. So first, in this example, we have a class commission employee. So this class has some data like private string first name, private string last name, private string social security number, private double gross sales, private double commission rate. Right. Then we have constructor public commission employee 3. It gets some inputs a string first, a string last, and a string SSN. Double sales and double rate. So first name B first, last name B last, social security number B SSN, then for gross sales and commission rate we have, for example, set gross sales sales and set commission rate. I will explain this too later. So first, let's set the first name public void set first name string first. So first name be first. To return first name, public string get first name. And we are going to return the first name. Then we will set the last name. So public void set last name string last. And last name is going to be last, right? Then we will have another method in order to return last name. So public string get last name. And we are going to return last name. Public void set social security number string SSN. And we are going to set the social security number to be SSN. So social security number be SSN. Then we are going to return social security number. So public string get social security number. We are going to return social security number, right? We will have some other methods the same for gross sales amount and commission rate. So public void set gross sales double sales gross sales be sales if sales is less than 0. It will be 0, else it will be sales, right? And a method for returning, so public double get gross sales return gross sales. Public void set commission rate double rate. and we are going to set the commission rate. So commission rate is if rate is greater than 0 and rate is less than 1, then it's going to be rate. Else it will be 0. We have another method for returning the commission rate. So public double get commission rate return commission rate. Then we have another method to calculate the earning. So public double earnings, it's going to return the result of get commission rate multiplied by get gross sales, right? And the last method, public string to string, it's going to return a string dot format a string dot format %s, because they are going to be a string, right? %s and then commission employee get first name get last name Then social security number is get social security number cross sales get gross sales commission rate get commission rate right. So this is the class that we have, the first class. Then we have another class that inherits from this class. For example, base plus commission employee 4. So it extends commission employee 3. It has a private double base salary has some constructors. So the first one is public base plus commission employee 4. String first, string last, string SSN, double sales, double rate, double salary. It's going to invoke the constructor of the commission employee 3 class. So super first, last, SSN, sales, and rate. And then it's going to validate and store base salary. So set base salary be salary. Right. This is the first constructor. I will explain the set base salary in the next minutes. So the method public void set base salary. That's a method for setting the base salary. It receives the salary, right? And it's going to assign value to base salary variable. So when salary is less than 0, let it be 0. Else, let it be salary. Then we have public double get base salary. So here, this one is going to return the base salary. We have another method for calculating the earnings. So public double earnings. So it's going to return get base salary plus super dot earnings, right? And finally, the last method, public string to string. It's going to return a string dot format. So here we have %s because it's a string, right? We are going to print the string. %.2f. Base salary super dot. We are invoking the method to string of the superclass. Base salary get base salary right. So this is the method that, as you see, inherits from this class inherits from the class commission employee tree, right? And finally we have the class that is going to contain the main method, right? So we call it to be, for example, polymorphism. So here we have public static void main string args First, we are going to assign superclass reference to superclass variable. So commission employee tree, commission employee B new commission employee tree. Right. So the name, for example, is Sue Jones. This is the social security number. And finally, we have, as you see, the gross sale and commission rates, right? It's on capital C, right? And then we are going to assign subclass reference to subclass variable. So base plus commission employee for B base plus commission employee B new base plus commission employee for Bob. The name is Bob. First name, the last name is Louis. This is the social security number. Right. In the next step, we are going to invoke toString on superclass object using superclass variable. So how? System.out dot printf %s, since this is going to be a string, call commission employee increase to string with a superclass reference. To superclass object commission employee dot to string, right? In order to call this method. And then we are going to invoke toString and subclass object using superclass variable. So commission employee 3, commission employee 2 be base plus commission employee right. And then system.out.printf %s call base plus commission employee for to a string with superclass reference to subclass object, and it's going to call the toString method from commission employee to, right? So commission employee 2 dot toString, right? So let's run the code and see what is the result. So as you see, we have call commission employee 3 to string with superclass reference to superclass object, right? So the commission employee, the name is Sue Jones, the social security, this is the gross sales, commission rate, and call base plus commission employee for to string with superclass reference to subclass object. So here you see the first name and the last name, the social security gross sale, commission rate, and base salary.